Welcome to Chapter 4, Part 2, the chapter of money. Here's our learning objectives. So in this chapter, we'll show you how we can modify the time value of money equations and use it for compounding and discounting rates of cash flow streams. That's what we'll be doing in our first couple learning objectives. And also we'll be distinguishing the different types of loans. So there's 3 different types of loans we'll be discussing. Also, we'll be building an amortization schedule and also rearranging the equations to determine weighting and interest rates. And finally, we'll be applying the time value money concept of lottery cash flow. And we'll show you top 10 essential points of the time value of money. First is our future value of multiple payment streams. Okay, so when you have an unequal amount of payments, you have to individually calculate each future value and then total them together to get the future value of the multiple cash flow. Here's an example in terms of a timeline. So you can see, as you can see, these are uneven cash flows. Okay, so in this case, 2,000, 3,000, 4,000, finally 5,000, and we're trying to figure out the future value. So in this case, we're trying to find the future value of $2,000 in the end of year 3. So you can see here, we'll have to make a calculation for this value here, another calculation for timeline 1, and so forth. And you can see at the end, we're just going to add them all up, and then we can figure out that future value of all of the payments. So an example here, if Jim deposits $3,000 today in an account that pays 10% per year, follows it up with 3 more deposits at the end of each of the next 3 years. Each subsequent deposit is $2,000 higher than the previous one. So in other words, it's going to be an uneven cash flow. How much money will Jim have accumulated in his account by the end of year 3? So again, to take a look at this, you can see the cash flow, $2,000 more every year, okay, so beginning with $3,000, and we're just trying to figure out that future value. So you can see eventually we're going to total them all up. But again, don't worry too much about the calculations. We'll be doing more when we look at our homework. Next is our future value of an annuity stream. So unlike the uneven cash flows, annuities are equal payments, okay, so in this case, we're getting an equal either inflow or outflow. Okay, so for instance, if you're paying rent or a lease or car, or perhaps you're paying into a retirement annuity payment, those are all even. One thing to consider also is an annuity can either start at the beginning or at the end of each payment. So if it starts at the beginning, that's what's called an annuity due. So in other words, it's due right at the beginning of the time period. Whereas if it's just an ordinary annuity, okay, so if it's not a due annuity, then it would be at the end of the period. So that's more common in mortgages or loan payments. Again, we have our formula here, okay. But of course, we can figure out how to use this through our spreadsheets, more details on that. But here's an example. So in this case, Jill's faithfully been depositing $2,000 at the end of each year since the past 10 years into an account that pays 8% per year. How much money will she have accumulated in the account? So, I mean, we can take a look at it individually, right? It's just like we did in example 4.1, where we calculated the future value of each payment, okay, up until the 10th year. And we've totaled them all off here. But we can also figure it out through our calculator or through our spreadsheet. And when we talk about our spreadsheet, we're going to be using what's known as our payments. So this is our annuity payment. In other words, it's an even payment that's going to be paid out. So in this case, again, we have it as a negative because we're paying into it. And you can see the number of periods is a 10-year. We have our rate. And because it was paid at the end of the year, we have our type as 0. Okay, so if it was an annuity due, then this type would actually be a 1, just as it says here. Okay. Now, when we take a look at interest rates, this is a good graph to sort of demonstrate how important they are in terms of growth, right? So if we have an interest rate of only 2.5%, when we invest that $100 at the beginning of the year, after 20 years, it's just over about $2,000. But as you can see, when the interest rates grow, that value grows substantially as well. So that's the future growth, but we can also figure out our present values of annuities as well. So we can take a look at it from the other way. So again, this is annuity, but now we're trying to figure out the present value. And we'll take a look at an example here in just one moment, okay? But we'll look at the timeline. So in this case now, we know that we have our values of $250 in the future, okay? But we want to know how much that value is worth presently. So we're actually moving that money back in time to figure out what we presently need to save for, or we need to provide in order to be able to have that money in the future. So example here, John wants to make sure that he has saved up enough money prior to the year in which his daughter begins college. So we're creating a college fund. So based on his current estimates, he figures that college expenses will amount to $40,000 per year for 4 years. So in other words, when his daughter is ready for college, he wants to make sure he has $40,000 every 4 years during that college time. How much money will John need to have accumulated in an account that earns 7% just prior to the year that his daughter starts college? So again, whether you want to use the math behind it, but we'll take a look at it from point of view of the spreadsheet, okay? Again, you're going to use that payment here. And in this case, we have 4 periods. The rate is 7%, and we're going to be paying it out at the end. So that's why we have our type 0. So in other words, John needs to have $135,000 currently to be able to provide that amount for his daughter when the college begins and be able to pay out $40,000 a year.